Hello everyone, greetings from VNR JYOTHI Institute of Engineering and Technology. This is by Manohar Reddy, Department of Cybersecurity, Data Science and AIDS. In this session, I am going to explain about the page replacement techniques, continuous the session. So, in the previous session, we have discussed about the first in first out page replacement process. So, how it works and what are the page faults, how many page faults are occur, and what is the impact of the page faults to enhance the system performance, right? So now continuing the session, the second algorithm is the least recently used one, LRU algorithm. So the LRU works replaces the page that has not been used for the longest period of time. So that means when the pages are full with the main memory, when the pages are full with the main memory, that main memory is full with the pages, it replaces processment occurs. The process page replacement occurs. So it replaces the page that has not been used for the longest period of time. So whichever the page is not been used for the longest period of time, that page has to replace. In the first in first out order, the first page, whatever the first page is inserted into the memory will be removed. But in this least recently used one, the longest period of time, the page which has not been used for the longest period of time, that page we have to remove. That page we have to remove and replace new one. That assumes that page used recently will likely be used again soon. So the most most recently used one we can use, but least recently used one may not use or may be used, and it offering better performance than first in first out order. We cannot say that this is a good one compared with the first in first out order, but we can say that it gives better performance than first in first out order. So when a page fault occurs, the algorithm replaces the page that has been unused for the longest time. So unused for the longest time. The main idea is to replace the page that has not been used for the longest time. So once the pages are loaded into the memory, which page is not used for the longest period of time, that page we have to remove from the main memory. So whatever the page which we cannot use it for the longest period of time, that page we have to remove from the main memory. So here the flowchart, how the flowchart or algorithm works, we will see here. So the first the page string starts here. Initialize the frames, that means the number of frames we have to initialize. So frames 3 or frame 4 or frame 5 decides that the number of page strings or number of frames. Based on that we can divide that, initialize the frames, and empty page list. So you can create the empty page list. So page strings occur and frames are ready, and read next page from reference string. So once a page string is ready, like 1 2 3 4 1 2 5 like this, if page string is ready and the frames are ready with 3 frames or 4 frames, once they are ready, the page strings are entered into the main memory. Pages are entered into the main memory. So begin page in memory. So if page is in memory, then it update directly in the usage order. So once the page is loaded into the memory is full, now the page replacement starts to work. That means now new pages are arrived to the memory. The oldest page has to be removed from the memory, and the new pages which are requested, which are arrived at the main memory, is to be replaced with the oldest one. So read the pages from the page string. One by one page is to be read from the page string. Once the frames are full with the pages, once the main memory is full with the pages, now next page is ready to load into the memory. At the time the page which you want to requesting to load into the main memory, the page is available, then update the usage order. If the page is not available, suppose one you want to load the next time, so that page is not available in this memory. Now free frames are available, then use that one. Free frames are not available, then identify and replace LRU page. So identify and replace LRU page. Suppose 1 is loaded, 2 is loaded, and 1 2 3 is also loaded. Now which page, fourth page you want to fourth page you want to load. So once the frames are full, once these frames are full, now fourth page is requested to load. Out of these 3 pages, which page has to be removed? That which page has to be removed is depending upon the least recently used one. Least recently used one. So out of these 3, least recently used one is what? 1, 2, 3. The 1 is the least recently used one, and 3 is the most recently used one, right? So at this case we can remove this one. We can remove this one and replace 4. Like this we can do. Identify and replace LRU page. So update usage order and increment page fault count. So like this we can work. If page frame is available already in the memory, if suppose next page is what? Next page is 2. Next page is 2. 2 is already available in the memory. So page hit occurs. Page hit occurs. So insert page into the free frame. Free frame is available. Insert page into the free frame and update the usage order and do that process. And if more number of pages are available, then do the page replacement process till the page string has to be completed. Do the page replacement process continuously till the page string has been completed, right? So like this we have to understand the flow chart. So now coming to the example, the reference string is what? 1, 2, 3, 1, 4, 5. So let us take the reference string 1, 2, 3, 1, 4, 5, and with the number of frames are 3. So we have to draw number of frames are 3. So F1, F2, F3. 3 frames we have to draw. So how the replacement process works here? We'll see. So as it is the first out order, we can inserted. We can remove the oldest page from the main memory and replace requested new page into the memory. But in this LRU, least recently used one, we have to remove the least recently used one from the memory, and we can replace the new arrived or requested page into the memory. We'll see first how we can insert the pages into the memory. So first, initially the pages frames are empty. Initially the main memory is empty, so we can move page into the memory. So 1 is moved to the memory and the remaining 2 slots are free. Page fault occurs. So automatically we can say that what? Whenever the frames are empty, new pages arrive to the frame, new pages arrive to the main memory, page is loaded into the memory, then page fault occurs. Now the second page which you want to load. So still 2 frames are empty. Still 2 blocks of main memory is empty. So we can move page into the memory. So page fault occurs again. Still 1 frame is empty and we are looking the requested page to load. The third page is ready to load. So load the page into the main memory. Now 3 pages are loaded into the memory. 3 frames are loaded. 3 frames are full with the 3 pages. Now the fourth page which is requesting to the memory to load, which is already available or not, check it first. The new page is what? 1. The page number 1, page 1 is requesting to load. But is that already available in the main memory or not? Yes, already available in the memory. So we can say that it is a hit. We can say that it is a page hit. We already said that what? The page which you are trying to load into the main memory is already available in the main memory is page hit. If it is not there, then load page into the frame so that page fault occurs, right? So now page which you want to load, the page is already available in the memory, so page hit occurs. Now the fourth page is ready to load into the memory, but already frames are full, main memory is full. So now which page you want to remove? Which page you want to remove means we have to follow the principle least recently used one. So take the direction, take this direction. So already used pages are this one, 1, 2, 3. 1, 2, 3 pages are already used. But out of these already used pages, which page has been used last time? Which page has been used last time means we can see 1 page we have used in the previous, just before that one only, and 3 page after 1 we can utilize it, and 2 is the longest period of time. 2 page is the longest period of time page. So we have to remove that page 2 and replace 4 page. Replace 4 page. So 1, 4, 3. 1, 4, 3 is available, and we have done replacement process. So page fault occurs automatically. And similarly, the next page, 5th page is arrived to the main memory, and out of this 1, 4, 3 still frames are full, and out of these 1, 4, 3 pages, which page we have to replace? So take the direction 1, 4, 3. So 4th page is just now we used, and 1 page is just before that we used, and 3 page is not used for the longest period of time. So remove this 3 page. Remove this 3 page. 1, 4, 5. 1, 4, 5. We can say that the page is loaded. 1, 4, 5. So we can replace this page, and the page fault occurs. Page fault occurs. Right. So this is the way we can perform page least recently used one page replacement process works. So compare with the first in first out order, the string was given more number of page faults in the first in first out order, but in this case one page fault has been reduced and one page hit is occur. So total number of page faults are 5 and page hits are 1. So we can calculate page fault ratio and page hit ratio also. So how we can calculate page fault ratio is number of page faults divided by total number of pages into 100. So number of page faults occur, how many? 5 number of page faults occur divided by total number of pages are available, 6 into 100. So total 600 divided by 6, 500 divided by 6, 8 ja 48 and 20, 6 3 ja 18. So 8.3 is the page fault ratio. 8.3 is the page fault ratio. And page hit ratio is what? 1.7 is the page hit ratio. So obviously page fault ratio is 8.3 means 110 minus 8.3, 1.7 is the page hit ratio. So like this page least recently used one page replacement process works. So always checks that the page string which page has been used longest time. That means since last time what page we used, remove that page and replace the new page. So here the page faults are 5 and it is the advantage is what? Better than FIFO. But we cannot say that this is the best algorithm. We can say that better than the first in first out algorithm, right? And the slightly complex to implement. It is somewhat slightly complex to implement because we need to compare the previous used pages. Why we are comparing? Out of these previous used pages, which page has been used longest time? So that is the thing we have to consider. Right, this is the way we have to understand the least recently used one. And the next algorithm is what? Optimal page replacement process. And out of these three, the third algorithm is optimal page replacement process. And here it replaces the page that will not be used for the longest period in the future. And LRU least recently used one is what? Will not be used for the longest period in the past. So in the past what page we are not used for the longest time, that has been removed from the main memory. But in this optimal page replacement process, the page that will not be used for the longest period in the future. So that is the thing, that is the keyword we have to understand. And it offers the lowest possible page fault rate. So it offers lowest possible page fault rate. So compare with those two algorithms, optimal page replacement says that what? It gives the lowest possible for page faults. But it is impractical because it requires a future knowledge or future references, page references. Maybe that can use or may not be that can be used, right, in the future. So that is the way, that is the thing we can say that it is somewhat impractical. The main idea is to replace the page that will not be used for the longest time in the future. This gives minimum page faults. This gives minimum page faults compare with those two, first in first out order as well as least recently used one. So how it works, we'll see. So here the flowchart of how it works for the optimal page replacement process. So first initialize all the frames and empty page list. Read next page from the reference string. So once the page reference string is ready, we can read each and every page into the main memory. So if the page in memory, yes, then go for the continuous to the next page. If pages are not available in the memory, that means the free pages are not available in the memory. If the pages are not available in the memory, is that frame is free or not? Check it first. If the frame is free or not, check it first. If free frame is available, if free frames are available, insert page into the frame. Insert page into the frame. If free frames are not available, that means already with some pages, look ahead in reference string to find page not been used for the longest period of time. So which has not been used for the longest period of time. Check the comparison. Which page we are not using, we will not using in the future for the longest period of time. Check that string, check the pages. If any page found, replace that page with removing this oldest page, right? So that is the way we can do things. So replace the page with new page and increment the page fault count till the page string completes. So if any more number of pages are there, do the same process till the page string completes. If no pages are available, then we can say that it is the ending of the process, right? So this is the way we can understand the algorithmic flowchart process. So let us take an example, the reference string 1 2 3 4 1 2 5. So 1 2 3 4 1 2 5. We remember that the condition is what? To which we will not use it for the longest period of time in the future. So how we can implement that, we will see here. The page reference string is what? 1 2 3 4 1 2 5, right? So frame numbers are 3. So we can write frame numbers are frame 1, frame 2, frame 3, right? So 3 frames are available. And a page string arrived to the main memory. Now start to do the page replacement process. So initially frames are empty. The page is arrived at the main memory. The first page is arrived to the main memory, load into the memory. So 1 is loaded into the memory, remaining 2 frames are empty. So because of loaded into the memory, page fault occurs. And still 2 frames are available. So load second page into the frame. And because of replacing that page, loading that page fault occur. Still 1 frame is empty, third frame is empty. So load new page, load third page is into the frame. We can occur page fault occur. We can say that page fault occurs, right? Now in this condition, the page faults are 3. And frames are full, right? Now the new page is arrived, the page number is 4 is arrived, but out of these 3 pages we have to remove any one of the page. But how we can remove and what page we can remove, right? So in the first out order, whichever the page comes first, the first page is to be removed, right? But in the LRU, least recently used one, in the direction which page has been not used for the longest period of time in the past, so that page has to be removed. But now the optimal page replacement process, out of these 3 pages, in which page we will not use in the future for the longest period of time. Suppose the one, if we see in this direction, is the one page we are going to use in the future? Yes, one is available, so definitely we are going to use. And 2 pages there, 2 pages available, yes, in the next future 2 pages also available, we are going to use. And 3 pages not available here, 3 page is not available here. That means the page 3 will not be used for the longest period of time because of the page strings are not available, right? So the 3, we have to remove this 3 and replace 4 as the new page. So this is the way we can remove the pages as per the principle of optimal page replacement. So here 1 is same and 2 is same, and remove this 3 and replacing this 4, right? So because of that removing process, page replacement works, page fault occurs. Now the next page is what? 1 wants to load into the memory. Before loading into the memory, checks that as per this algorithm, is that page in memory, is that page is available in the memory or not? If yes, then continue. If no, free frame is available, then do the process. So now here what we can say, the 1 to 4 already frames are full with these pages, and the page which you are trying to load into the memory is what? 1, and 1 is already available in the memory. 1 is already available in the memory, so page hit occurs. 1 is already available in the memory, page hit occurs. In the same way, the next page is what? 2. So 2 wants to load into the memory. Before loading the memory, is that 2 is available in the memory or not? Is that 2 is available in the memory or not? We need to check the two conditions. One is what? Before inserting any page, is that free frames are available or not? If no free frames are available, then check the second condition is what? If the requested page is already available in the memory or not. The requested page is what? 2. Is that 2 is already available in the memory or not? Yes. So what we can say that the 2 page is already available in the memory, so the page hit occurs. Page hit occurs, right? And next we need to replace the 5 page. So to replace this 1 to 4 out of these 3 pages, which page we cannot use it, we will not use it for the longest period of time in the future. Is there any page is available? If we reverse the string, the 1 is available, 2 is available, 3 is available, 4 is available, but next one is not available. So the 1 page is not available, so we can remove this 1 page and replace 5 into the queue, right? 2 and 4, page replacement done, page fault occurs. So this is the way we can do the page replacement process of optimal page replacement. So in this how many number of page faults occur? So total number of page faults are 4 plus 1 5, and the total number of page hits are 2. So compare with the previous two algorithms, first in first out order, total number of page faults are 7, and the previous LRU total number of page faults are 6, and here the total page number of page faults are 5. So how to find the page fault ratio? Page fault ratio equals to total number of page faults divided by number of pages into 100. So total number of page faults are how many? 5 divided by 2, total number of pages 3367 into 100. So 500 divided by 7 equals to 7 7 ja 49.72 ja. 7.2 is the page fault ratio. And similarly page hit ratio equals to number of page hits divided by number of pages divided by number of pages into 100. Number of page hits are available 2 divided by number of pages are 7 into 100. So that is nothing but 200 divided by 7 is nothing but 2.8. 2.8 is the page hit ratio. So that is 7.2. So as per this minimizing the page faults, so compare these three algorithms, the optimal page replacement gives minimizing the page faults and maximizing the page hits. Compare with those two, right? So this is why it is saying that it is a best algorithm, and but disadvantage is what? It is may not be practical because the future references are not known. So here example we take like this: 1 to 4 future references are not known, So we can take any one of the string, right? So this is the way the page replacement of optimal page replacement works. Now comparisons of page replacement algorithms. So these are the things, how and what idea, what basis we are going to perform these algorithms, what decision it is going to take, and how we can implementation, and what is the difficulty level of the implementation, and what are the number of page faults, and practical usage, memory overhead, and performance, example, removal rule, and melodies anomaly. So all these points, all these parameters, all these features, the first in first out is what the basic idea is to remove the oldest page, and LRU removes the page that was not used for the longest time, and here will not be used for the longest time in future. So on these ideas the page replacement process works, and the decision is based on arrival time of pages, and past usage of pages, and the future usage of pages, right? So which process comes first, which process comes world, that has been removed. So that is the arrival time of pages, and the past uses of pages which are used in the previous will not be used for the next time. So that is the past uses, and future uses pages which will not be used for the longest period of time. And implementation difficulty level, the first in first out is implemented in very easy manner, but it does not reduce the minimizing the page faults, right? And LRU is what, moderate, and the optimal page replacement is what, difficulty level. And the number of page faults, usually first in first out order more number of page faults are occur, and LRU less faults than first in first out order, and optimal minimum possible faults. And the practical usage, it is used in simple terms, it is used in many practical systems, and it is mostly used for comparisons and analysis. And memory overhead, it takes very low memory overhead, and it is higher needs tracking the usage, and it takes very high. And in performance wise, the first in first out order gives lowest performance, and it is better performance, and it is best performance. And example, remember, first page load is removed, and a page not used for longest time is removed, and a page used furthest in the further is removed, page used farthest in the future removed. And the melodies anomaly is what, it is possible, it does not possible, it is not possible. So these are all the different comparison features of all these three page replacement algorithms. So finally we can say that optimal page replacement is best algorithm for page replacement process, but we can say that it is difficult to implement in the manner, right? So I hope all of you understand all these page replacement algorithms. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.